welcome everybody to this week's community call. It's been a busy week. Hopefully everybody had a great week, just like we did. I'm going to give people some more time to join, just a few minutes, maybe half, maybe one. In the meantime, I'm going to introduce my lovely new co-host, Vesta. Hi, Vesta.
Hello. Very
And
happy to
also
be here.
we're also happy that you're here. And also our guest for today, who's going to be our main show, basically, who you already know, Claudia Diaz, our chief scientist.
Hello, everyone.
Hi there. Well, before we get into the meat of this community call, we're going to do a quick news roundup. But before that, I'm going to share with you all that that this community call, as you know from the announcements, is dedicated to Data Privacy Day, which is not today but tomorrow. But it's we can't start celebrating too early. So basically, we're trying to raise awareness and promote privacy and data protection best practices, because people may not value data privacy as something serious because it's very abstract and it's a complex problem that is not really tangible for most people, especially not for most people in the West, because we're pretty safe here. We don't need to worry about oppression for the most part and surveillance that affects us in some direct way. We are surveilled all the time though, and we wanted to have a special community call where we explain the nitty-gritty and also the base from the basics down to the nitty-gritty of one of the most common and most impactful ways of surveillance that is happening all the time, metadata surveillance. And for that, we need to explain what metadata is and how it works. So that's what we're going to be doing today. But before that, we're going to be giving you the usual news roundup so that you can catch up with what happened to the project over the past week. Oh, and one more quick thing. As usual, if you have any questions or comments or anything that you would like to share with us during the call, then you can do that on the dedicated community call text channel, which is 2 above the stage that you're currently on. We're keeping an eye on that channel, and if you share questions there, then we're going to be answering those during the call. So let's get started. What do you have for us, Vesta?
Cool. So during the week, the COO, Alexis Roussel, was found in IDF rights in Paris. He was a featured speaker in a debate on fundamental rights in the digital world. And also what happened during the week was, so the European Central Bank, ECB, recently announced a market research exercise on possible technical solutions for a digital euro. So the NIM team hopped on board. The core research and development team gave their first take. They didn't hop on board, but they gave their first take on the digital euro technical requirements. And I'll pop the article link through because it's really interesting. And overall, while the ECB put forward quite a detailed and well thought out set of technical requirements, where they do appear to take privacy seriously. I think NIM in general concluded that they do stress that the entire digital euro implementation will require careful privacy considerations and further analysis. So there's a way to go. Like they seem to be taking it seriously, but there's still some steps. So you can kind of get through the technical elements in that piece. And also, another great thing happened. We had our first Portuguese Twitter space, which happened yesterday. It was about Web3 privacy, and it was hosted by fellow Universal Privacy Alliance members, Zcash Brazil, and Portuguese-speaking Secret Network. So that was great. And I'll pass it on to you, Simon, for some other updates.
Thank you. So the other thing that also happened this week was the third installment of our bi-weekly DevRel AMA, and I wish I could share a link to the recording of it, but I have a huge backlog of YouTube uploads, which I apologize for. I just don't ever have the time to export and edit the videos. So I think at this point I owe you guys 3 community call recordings and also 3 DevRel AMA recordings, which I'm going to, at some point, I promise that I'm going to catch up on. So basically, these DevRel AMAs are but they're similar to community calls, but these community calls are structured. We come with ideas of what we want to talk about, and there's less space for actual discussion. And DevRel AMAs are more developer focused and technical focused, and also allow for kind of an open discussion where you ask questions and our DevRel team answers them in detail. I really enjoy these. I think they are great. So if you want to attend the next one and ask your questions live from our DevRel team and also myself and Donny, my other co-host, then make sure to keep an eye on our channels because the next one will be 2 weeks from now.
And
And
I
sorry, go ahead.
encourage lurkers as well. Sorry to butt in, but yeah, I also lurk in those DevRel AMAs. It's just a joy to kind of learn, even if I'm not a developer.
Yeah, so you don't need to be a developer. It's not always very technical and very heavy and development focused. We also discuss some lighter topics, whatever you guys ask, basically. So yeah, lurkers are definitely welcome, and anybody else is welcome, of course. So that's a good point, Vesta. Thank you. Now moving on to our next news item, our Latin American team um, were at Block World Tour in Granada this week. That was, I think, yesterday. So our advisor from Latin America, Daniel Vasquez, presented on NIM, Enabling Digital Privacy and Security for All Humanity, which I think is a really great title, and the presentation was also great. I'm not sure whether a recording was made of this event, but for a Spanish-speaking community, if there is going to be one, I'm going to make sure to share it on all our channels. I'm pretty sure that it was a very exciting presentation over there. And something else also happened yesterday. Yesterday, our CTO Dave attended Cosmos Club. There was a Twitter Space hosted by Cosmos Club, and it was a really fascinating conversation. I'm going to share a link to it in the chat.
I just did.
Oh, nice. Thank you. Thank you. So it was a really interesting chat, especially because most of the things, of course, me as someone who's working for NIM, I've heard most of the topics covered, but it was a brand new perspective that I never heard it from before. So Dave was really going back to the beginnings, and he shared some insight on his decision-making process as CTO of NIM, why he ended up choosing the Cosmos ecosystem rather than something else. And many other things like that, which I never actually heard about before. So it was an absolutely fascinating conversation. Hopefully, no, not hopefully, but I know for a fact that it was recorded. So if you visit the link that Vesta shared on the dedicated community called text channel, then you can access the recording. And I definitely recommend giving it a listen because it was a really interesting talk about NIM and NIM technologies, including ZK NIMs and the MixNet and much more. And one thing that I am going to be announcing, our next news item actually, is something that I'm announcing now. So recently, as many of you know, we renamed what we used to call Coconut Credentials. That has been their name for the longest time. We renamed those to ZK NIMs. Now, we like the name. Not everybody likes the name internally, but most people do. And the name is not final yet. So basically, we wanted to give you the opportunity to give us some feedback on the name ZK NIM and maybe give us some additional ideas on what you would call our zero knowledge credentials. So if you want to chime in, if you want to share your opinion, we just shared a Dino form, which you can fill out, and then you can help us out with the process. This will also be announced on our Telegram channel and our Discord on different Discord channels, and we're going to be trying to gather your feedback over the coming few days. And I think that was all that I had in terms of a news roundup for today. So we're moving on to the meat of today's community call, which is going to be Claudia. So actually, it's really funny that I have you on today, Claudia, because you were my first guest back in April 2022. You were my first guest on the first community call I ever hosted. I remember I was incredibly nervous about, not because of you,
You
but
did great.
thank you. Just public speaking in general. I had a huge sweat spot under in my armpits. I was really nervous. A lot has happened since then. Now we have co-hosts, we have a proper format, and we have specials. So that's what brings you here, the Data Privacy Day special. I'm really excited to have this talk with you today.
Yeah, thanks a lot for having me here.
Vesta, you want to get
Cool.
started
Well,
with the...
yeah. I think let's get to it. So data privacy is one thing, as we all understand, but unless we have metadata privacy, I think we don't have privacy at all. Even if our communications are encrypted. But before getting any deeper into to understand this better, would it be possible, Claudia, to first touch on what is metadata, specifically communications metadata?
Yes. So metadata is data about data, right? So generally in communications, you would think as the data, the thing that is actually being communicated, the data that is being the payload in a way that is being sent from a sender to a receiver. This would be the data. And the metadata is all the data that is incidentally generated by the mere fact of the existence of this transmission, right? So this includes the origin of the communication, so who sends it, the location of the sender, potentially, who is the destination, and potentially the location of the destination, at what time the communication is taking place, how many bytes are included in this communication, so what's the volume, how long does it take to communicate the data, and any detectable patterns that you might have in the communicated data, in the sense of number of packets, timings between the packets, and generally assuming that the actual payloads are encrypted with a secure algorithm and cannot be decrypted, then everything else that is in the data packets, in the headers, and things that are implicit, such as the time when a packet was seen on the wire, all of that constitutes what we can call communications metadata.
So another important question when it comes to metadata that I think not a lot of people realize and understand is who has access to our metadata. So who has access to your metadata and mine when it comes to our communications online?
Yeah. So the thing is that when we are transferring information from one place to the other in order to communicate over the internet, there's a lot of intermediaries in this communication, right? So, for example, I might be sitting in a public space that has a Wi-Fi, right? So the first intermediary would be this Wi-Fi router, or anybody really who is in the room and can eavesdrop on my Wi-Fi communications, right? So that would be the first intermediary, the Wi-Fi operator. Then this might go through some sort of local network, which might have other people who are operators there. And then this goes to the internet service provider, ISP, that is providing internet to this bar or restaurant that has Wi-Fi. They are also intermediaries in the communication. And then you go into the kind of internet backbone infrastructure where you have many entities running autonomous systems, internet exchanges, BGP routers. There is a whole ecosystem of infrastructure providers, and then things will be directed towards the destination, and then you will go again potentially through local networks to get to the destination. So there are many intermediaries, basically. So you have anything from local intermediaries such as the Wi-Fi provider or local network operator to kind of large internet infrastructure intermediaries that can see the communications of a large part of the internet, not just like the people sitting in a certain cafe using the Wi-Fi. The thing with metadata is that even if the content, if the payload is encrypted, the metadata is exposed by default in internet protocols, right? So TCP/IP exposes metadata because in order to route the packets, the routing algorithms need to see the destination so that the destination will be visible. They also want to see the sender so that if there is acknowledgements or any authentication needed, they can also do that. The time when it happens is the time when it happens. Anybody who has a watch can check the time when a packet was sent. And the size of the packet, I mean, you can always pad it to make it bigger, but it's not always done by TCP/IP. So basically, these internet protocols, TCP/IP, but also things like FTP or even secure protocols like TLS or secure DNS that encrypt the payloads, they will still expose who sends, who receives, when it is sent, how many bytes, and what is the interpacket timings between packets and the length of the packets. So yeah, basically it is exposed by default in the routing protocols. And then at the same time, it is available to a large number of parties who have to interpret this data in order to route the communication from the sender to receiver and make it happen.
And I'm curious to know, would you know, like, for example, some of the earliest examples of when people were starting to see, metadata as something useful to be able to discern information?
Yes, this is as old as humanity, I think.
Mm.
So
Yeah.
metadata and traffic analysis, this is kind of a terminology we use in the research community, right? Traffic analysis. This is basically what in military terms is called signals intelligence, SIGINT, right? So in intelligence, you have basically human intelligence, which is spies that, have some double life, and then they talk to people and they find things out and they report them. So this is one kind of branch of intelligence gathering. And then there is signals intelligence, which is basically looking at electronic communications. I mean, you can also do signals intelligence by looking at people coming in and out of a building, what time they come in, how long they stay in, when they go out, do they come alone, do they come with somebody? This would also be kind of a metadata analysis, right? In a kind of an analog physical world. But signals intelligence with electronic communications, I mean, this has been done already. I mean, in World War I, they were wiretapping the returns of the kind of telegram channels, and then certainly already in World War II, so 80 years ago, this was a well-developed field where the use of signals intelligence did allow things such as the reconstruction of the aviation of the enemy by looking at the communications that are happening, the identifiers that are being used, and all of these patterns. They can reveal a lot about your adversary in a situation of conflict, right? So yeah, I mean, this is basically coming from an earlier tradition of signals intelligence, that now once these signals are not being used only by militaries but by everybody in civilian applications. So now we have kind of the same concerns of this information leaking and being useful to figure out what people are doing or any private information about them. This is now translatable as well to the world of the internet and to all of us, as our communications are digital.
All right, so this was the super important part that is relevant to everybody, but it was not so tangible. And also, we included some history, but still, people may have a difficult time understanding how this relates to their lives. So my next question will lead straight into that. Let's talk a bit about what examples of metadata we could list, and also what someone could discern about us from that metadata.
Yeah, so I mean, I can talk about a few examples of things that we have quite good research on, that have been demonstrated to be discernible through metadata analysis, traffic analysis, right? So one problem that has received a lot of attention is what is called web page fingerprinting or website fingerprinting. It has it's called in both ways. So the idea here is that if you go to a site that has HTTPS, you will reveal which site you're going to. So imagine you're going to WebMD, which is this kind of encyclopedia of medical diseases, and you can check the symptoms and the treatments and all of these things. It's one big site with lots of pages, one page per disease, one entry per disease, and then one site that contains all these pages, right? So if I see you going to this website, then I can learn already that you are interested in checking some medical information, right? But if there's like thousands or tens of thousands or even more pages you could be looking at, I will not be learning so much about what your concerns are, right? It could be anything. It could be flu, it could be cancer, it could be anything in between, right? So in that sense, having this HTTPS still reveals the site you're visiting, but conceals the specific information within this site. If the site is very big and has a lot of diverse information, then this is still kind of making opaque towards the adversary what you're actually checking. So what website fingerprinting does is that it kind of exploits metadata to be a sort of a side channel that allows an adversary who's looking at the communication to actually guess, infer, which specific web page you are visiting in this site. So how does it work? Because, I mean, the communication is encrypted, right? Like I see an encrypted communication between you and WebMD. I cannot read anything inside this communication. So how can I figure out which specific page you are downloading, reading? So the technique it would be the following. WebMD is a public site, like many sites on the internet. So as adversary, so I am the adversary now. What I'm going to do is that I'm going to go to WebMD and I'm going to download all the pages, possibly multiple times, maybe 10 times or 20 times every page. Okay. So I'll download them. I know which page it is. I'm looking at the page of whatever flu. So I can label this page I'm downloading. And then what I will do is that I will look at my network connection and I will kind of produce a data set that contains the timings and sizes of the packets going back and forth between me and WebMD, right? So I send a request packet, then a few packets come back. Maybe my browser then sends another request to retrieve additional resources that then will come back and so on. Because every page has different information. They might have different amounts of text, different layouts, different pictures included, and so on. Each of them will have a kind of a unique traffic signature. Okay, so the traffic signature here is the sequence of packets. And remember, the payload of the packet is encrypted, so we cannot read what's on the packets, but we can count packets. We can count packets, we can see how big the packets are, and we can see at what time they're coming and how spaced out they are from each other. And also patterns of like packets go from me to the site, and then from the site to me, and then from me to the site. So this kind of back and forth patterns. So as adversary, I will be downloading these pages multiple times every page, and I will be making like kind of a dictionary that says, okay, when this is the page I'm looking at, this is the kind of pattern I observe on the wire. And this pattern, if the page content is kind of static, is going to be quite stable, right? So every time I download, the pattern looks more or less the same. So I do this and I create a sort of dictionary, right? So now I have a dictionary that for each page in this site, I have a signature of packets, of how the packets look like on the wire when somebody's downloading this information, right? So now you're my target. Now you go to WebMD. I can see you're going to WebMD, and I can see a pattern of packets in your wire between you and WebMD. And now the question is, how can I guess which specific page you're seeing? So what I will do is that with the kind of all these downloads I made, I will train a machine learning classifier that then, given a sample, given a packet sequence, timings and sizes of packets, it will output the most likely label, which is the actual page, right? And this actually works very well, especially in this kind of scenario with HTTPS, where you have a closed world that WebMD has a certain number of pages. So if you're visiting WebMD, you must be visiting one of the pages from WebMD, right? So it works very well. And basically from the signature of the traffic on your wire, I can combine that with my previous knowledge of having downloaded all these pages, see which one it looks like on the ones I downloaded, and from there infer which one you're looking at. Okay. So this is a way in which, without breaking encryption, I am able to guess which resource you're receiving, and this is because of distinctions between resources in terms of sizes and layouts. Was that clear?
Yes, very much so. One question though. So you mentioned I'm being your target, for example. Just for the sake of example, I'm your target, and this is the process of you surveilling me through this method. Is
Yes.
this done target specifically though, or is it more of a mass surveillance strategy or technique?
It's more of a, so yeah, if the pages, this is it's a good question. If the pages are very personalized for some reason, which is not the case with WebMD, right? If you have a very personalized page, I might need to train on something that looks like your personalized page, right? Because then every person downloading the same page might have a different pattern, right? It's very difficult to use this with sites that have a private login and then, for example, your Gmail or whatever, right? Like I cannot train to see like things inside there because I don't have access to the same information as you. But when you have a public resource like a web page, a news site, a WebMD, anything like Wikipedia, anything like that, then everybody who downloads will roughly follow the same process, right? Like you might have small differences between browsers, mobile versus desktop, Chrome versus Safari, but generally these are rather stable. Um, so yeah, I mean, it actually does allow me to not only target you, but target anybody. The limitation is more when the web page is updated, then I have to update my training. Imagine that the flu page gets revamped because there is some new information. So I need to retrain to have the latest fresh version that you're going to be getting. Otherwise, if I have an outdated version, I might fail in the inference.
I see. Well, then I try to tease out something that that sets up for my next question, but my next question is going to be
More examples, right? I have more examples. I have two more examples if you want me to.
go ahead, go ahead. Yes, please go ahead.
Yeah. So another example takes this a bit further, right? And the two other examples I have, they are not new. They are already like a decade old, and I'm sure there's more work that has been done. But these were actually very impressive. So one of them is what they call web applications, right? So the web applications here, the idea is that this is some sort of interactive process in which the kind of content is partially, the inputs are partially on the client side and the execution is on the server side and the internet is in the middle. So the work I'm specifically thinking about, they considered three examples, okay? So one example was search autocomplete, right? So if you have search autocomplete, I start typing some letters in the search box, and then the server on the other side, these letters will be sent to the other side, right? And then the server on the other side, depending on which letters I typed, they will suggest how to complete the words, right? Or what search queries to send. So basically the response from the search server will be dependent on the letters I typed. If I type AB, I will get different suggestions than if I type HO, right? Then this was one of the applications they looked at. Another application they looked at was tax applications. So you have these applications that help you check how much tax you have to pay. So basically you land on a page and then they say, okay, are you married or single? Okay, so do you have children or not? Or do you earn more than this or less than that? So you have like drop down menus and you have to kind of select options, right? Depending on the options you select, the next step will be dependent on that state to offer you to provide more detail, right? Like, do you have children? Yes. Okay. So how many? Okay. And are they dependent? Things like that. So this was another application they looked at, and the third application was health. Again, similar to taxation, there are sites where you go and you say, okay, what is your problem? Is it a problem with your legs, your arms, your head? Is it pain? Is it redness? What is it, right? And again, here you have drop down menus, and then depending on what you select on the drop down menus, then the next step will be, refining whatever you said in the earlier steps, right? So these are the kind of applications they looked at. And of course, in these applications, this search, taxation, health, you have a lot of back and forth. And this back and forth is dependent on the choices that you have from a closed set of options, which are these drop-down menus or the letters in the alphabet that you can type and the combinations between them, right? So they apply this similar fingerprinting technique, which is basically to interact with the system you want to attack as adversary and to put the different inputs. So I would basically choose, systematically go through all the possible inputs. And for each of these inputs, I will record the traffic, the packets that are seen on the wire, how many back and forth, all the patterns on the wire of encrypted traffic, right? And then again, the technique is the same. I feed all of these encrypted traffic traces which are labeled because I knew what I was doing. I knew I was selecting, this option from the drop-down menu, labeled, and then you use that on a classifier. And then again, when the target is interacting with the system, and you see that they are doing some search, and you see that there is a certain pattern of back and forth packets, then you can feed that into your classifier that was trained with the different labels, and then it will output the label that corresponds to which letters are being typed, or which symptoms were input, or which taxation information was input in the drop-down menus, right? So it's a little bit like what's a fingerprinting, but here instead of having like just a set of static resources that you download one of them, you're having an interactive application, and the inputs were actually confidential, and this is why these systems actually have encryption in place, are supposed to be protected. And encryption does the job of protecting them to its limits, but then this traffic data acts as a side channel that is actually exploitable in order to recover these inputs. So this is another piece of work in this direction of how you can exploit metadata in order to retrieve private inputs, health, taxation, and key search keywords. And there is a last example I wanted to give, which is also some work from 10 years ago, where, and that has also, I'm sure there are follow-ups that improve on that, but this was already very impressive. And this was about decrypting encrypted conversations, phone conversations, voice over IP conversations, right? So basically here the idea, the kind of the key thing is that the system that was being attacked used a variable bitrate codec and a length preserving stream cipher, right? So the variable bitrate codec means that depending on the phoneme I'm speaking, if I say T or B or D or whatever, is gonna be encoded with different size of bits, right? So this is one piece. This is the plain text. But then this plain text becomes a ciphertext with a length preserving stream cipher, meaning that any variability in the bits, the number of bits and the spacing between bits is going to be preserved in the
Wow.
version.
Wait a second. So this means that basically the vowels, because of the bit rate, the variable bit rate, were basically how to say this, like were exposed from below the layer of encryption. Is that what you're
Yes,
saying? That's
yes,
insane. That's super
yes.
interesting.
So that's what they did exactly. They trained a classifier that basically from this variable bit rate pieces of data that are being sent, it kind of recognizes which phoneme it might be, right? So it makes an inference. And then that by itself doesn't give you the full thing, but then because there is so much redundancy in language, you can do a lot of error correction, right? So once you do the error correction, you're able to recover the encrypted conversation. And you didn't break the cryptography, which is incredible. So
It's
that's
incredible and
just
really scary.
yeah, it's just to illustrate the power of this metadata, how in some cases, it's not only that it can reveal content. This is kind of the most shocking thing, right? That you have secure encryption algorithms. They are not broken. The key is safe, but the metadata is a side channel that allows you to recover these encrypted inputs, right? I have to say, this is not the only bad thing that can happen with metadata. Other things that do not involve recovering content, but are actually I would even think the more original uses in signals intelligence is figuring things out about, for example, groups of people or organizations. You can identify who's the leader. You can identify who are the key people that make decisions. You can identify which are the sub teams. You can identify basically information about how practices of work and how people are organized by looking at how they communicate, right?
Two questions here,
Yeah.
if you don't mind. One is this all what you're saying right now is assuming encryption, right? Like something like a VPN or something.
Yeah.
That's insane.
encryption, you can have secure encryption. But I mean, even think about it, right? Like, think about maybe a good analogy that people can relate to is phone records. So the phone records don't have any content of the conversation, right? Like I called you at this time of the day, we talked for 5 minutes, and then that's it. And then I called someone else for 10 minutes, and that's the information you have, right? There's no content in the phone records. However, if you get like the full set of phone records, you can reconstruct the graph of who's calling who and on which sequence and for how long. And then you can start deriving things about which people are close. What is the nature of the relationship? Like people who talk every day 1 hour at midnight might have a very different relationship from people who talk 1 hour, during working hours. If things happen after the information of some event got to somebody, then you can infer that this person is a decision maker. You can identify which people are gateways between different communities. And of course, this has huge implications if people are self-organizing to do any kind of activity. Traffic analysis allows you to identify the targets, right? So I have something is going on. I want to maybe control things or stop things or figure out what's going on. But there's all these people, I don't know where to start. So traffic analysis would allow you to select targets, to see who are the important people. And then maybe I will use my more limited resources to send phishing to these people to try to compromise their phone, or to do human intelligence by having somebody approach them. But I already know that these people are valuable because the signals intelligence, the traffic analysis of the metadata allowed me to see that these are the people that, make things happen, or that are in the center of community, so that they have a special role that is visible via the interactions.
When they are kind of embarking on collecting this data and then using it as a case to, propose, like at some point people do have to like showcase how they've approached this, right? Like they'll say this is the information we gathered, and is that like?
It depends. I mean, I guess it depends, right? Like sometimes decisions are made and you never find out. Like I think these techniques are actually in use in marketing to, at least I heard about it like very long time ago. Like for example, to identify, so you have a bunch of customers, you're a mobile phone provider, whatever, you have a bunch of customers and you want to identify the influencers because you're going to give them some freebies. You're going to give them some whatever, nice free service, whatever, so that they influence their friends. You're going to give them a free phone, right? Because these are the people that everybody else is following. And you can see that because interactions, it shows like how they are kind of very central, and they have a higher degree than others. There's graph characteristics that allow you to identify influencers and use that information to give these people, to gain kind of the goodwill of these people in order to then attract more customers, because others will follow them if they are buying this brand or whatever.
In terms of just a bit of a lighthearted note, this is inspired by Pawnflake, who's written in the community call. He's said, this is so cool. So randomly adding resources to pages could really mess with this. I like this comment because I think some of us sitting here probably, were wowed by kind of hearing about this way of, understanding our metadata and our patterns. And we're probably maybe, thinking, just because after this call, who knows, we're going to use a computer a bit more. Are there fun, cheeky ways, or like, have you thought of like fun, cheeky ways that we can kind of just play around with this?
Yeah, I mean, of course, there's different techniques you can use, right? Like you can try to look like a different thing every time, look like nothing, right? Or you can try to everybody look the same. So you can design WebMD such that all the pages look exactly the same in terms of traffic pattern. So that means that the small ones you completely pad and you make them all the same, right? So this is one possibility. The other possibility is that every time somebody downloads a page, you're adding random resources and making it different. Right. So this is definitely going in the direction of what people usually do to try to come up with countermeasures. Of course, every countermeasure then, once you have adaptive adversaries, then okay, you're making them all the same, but are they really the same, or are there some small differences that I still give away that is one page and not the other? Like, for example, what about now whatever, maybe shoot down some of these packets, do you still get your page, or do you have, because it was garbage, that you're not missing any of your content? Or you see what I mean? Like, it goes into a whole cat and mouse game. Looking like nothing again has the same, right? Like, okay, so I'm sending every time random additional resources, but the resources I have to send, they always have to be included. So is the fingerprint still, is the adversary still be able to recognize that these resources that form the core of the response are present, even if there is additional noise? Is the noise enough to kind of bury the signal or not, right?
I have a community question, which actually ties into one of my questions that I wanted to ask you. So the community question is whether you have any article or maybe research paper describing these attacks, or more information about these attacks, because they are really scary.
Yeah, so there is plenty of research. I mean, the problem is that there is too much, and I am not sure if there is any good summary that, because yeah, all the research, everybody's like, okay, so now we take this problem and we do this, new tweak. I would be happy to share some kind of seminal works that I commented. So this voice over IP and the web resources, I can give the links. I can actually, I can even probably, let me just, maybe I can just, do I have a chat here where I can put stuff?
Yes, so you're on the NIM stage right now, and two above that there is the community call text
Okay.
channel. And if you go
Oh,
there, you can post the links there. But you can also just leave it with us, and I will share it with the community. We can also just gather some of the more important or more interesting pieces of research when it comes
yeah.
to this.
Okay, I'll put these two because these are the two I kind of talked about. And then I can try to dig out some for website fingerprinting. There is like so much. There's probably like, I don't know, 30, 50 papers on it.
Mhm.
If people want to get an introduction to this, probably the best is to have like some sort of what they call a systematization of knowledge, which is kind of a survey that gives a little bit the bigger context than what the state of the art is. Otherwise, papers tend to just spend too little time on setting the context and immediately go to whatever it is that they are doing that is specific to that paper.
Thanks for the question, Lebek. And this leads really well into the question that came to my mind as you were talking about this, because you said they looked into it and similar a lot of times. So when you say that, that means, or they looked at this, looked at that, that they means privacy researchers, right?
Yeah, I guess yes. I'm not sure I get the context now.
Oh yeah. So as we were talking about these topics, when you brought up the different methods
Yeah,
that
yeah,
you
yeah, yeah. The
yeah.
community, yeah, the research community.
Yeah. So my question is how what do you think the relationship is between the cutting edge of research, when they look at these things, like you guys, privacy researchers, versus what happens in real life?
Oh,
Is it like, do we have significantly more advanced techniques like this out there that we haven't stumbled upon yet, research wise, or is there good lockstep?
yeah, I don't really know, so I'm just giving a bit my educated guess. Right. Um, yeah. I mean, I have no idea what people are doing in like the NSA or whatever, right? Or how. I mean, my sense is that a lot of research is produced. Producing one of these papers takes usually like about 6 months of work of like a student and as a more senior person. It's not so easy, especially if you want to have like proper validation and experiments that are really properly done and reviewed and all of that. So I have the sense that the fact that something is possible in research doesn't mean that it's immediately deployed or that it's practical to deploy. Now, that said, yeah, some of the things in practice might be not so difficult to implement. So So yeah, I guess there is a diversity. You have to start looking into the assumptions, right? Like, are the assumptions of these attacks such that are likely to be met in practice by an adversary? In a way, maybe the assumptions are too hard. So in research, you say, oh, we assume the adversary has this and this and that, and then maybe you want to deploy the attack, and it's really hard to have those resources, that position that you need to do to conduct the attack. At the same time, to publish a paper, you need to have a lot of convincing evidence that it works. If you want to deploy an attack in practice, as long as you're satisfied with the workings of it, you don't need to convince anybody else, right? So yeah, I guess I'm saying that my sense is that in some things, the research papers are talking about things that are kind of futuristic from the point of view of the reality, and from other points of view, maybe the research paper is kind of restricting itself in the methodologies in a way that the real attackers don't restrict themselves so much, and they are able to get something working that is maybe not scientifically super well based, but it kind of works.
Being able to convey some of these things to, for example, maybe some of us want to share with our loved ones or other people, like, hey, some of these things are quite important. Are there any existing resources that help us kind of reveal facts about our metadata, or any patterns or anything that are like
About our
kind of
own
made? Huh?
It's actually hard. I mean, working on privacy research, right? Like, you realize that when you want, there's this whole discussions about privacy. Privacy is about control of your data, who can see your data, blah, 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 right? So when it comes to content, I think people are relatively well positioned to make decisions. Like, if I post something on Facebook or Discord or some other platform, I have an awareness that I'm posting something, right? I have an awareness of what I'm saying, and normally I should have an awareness of to whom I'm saying this, right? I'm saying this to the world, to my friends, to somebody in particular. But because I have this awareness that I'm saying it, I can have some control over it. Now, metadata is to content, in my opinion, this is an analogy I've used in the past, as body language is to what you say, right? So you control what you say, but you don't, controlling your body language is a lot harder, right? And you might be saying things with your body language that you're not intending to see or even aware of the fact that you're saying it. Metadata is about like that. It's a bit like that. Like, when you are browsing the internet, you don't have the sense that you're sharing any information with anybody, right? Not like when you upload a picture. So it's difficult for people to realize that the mere fact of just using electronic systems or just having a mobile phone in your pocket and walking around is basically generating these metadata traces that then are potentially exploitable for learning private information. How to communicate to people is a hard one, because it's not, these are, it does not, metadata often does not relate to volitional, to kind of volunteer actions that you're taking consciously with an intention to take them. You don't have an intention to send 1003 packets. You have an intention to just maybe share something, a comment, or put a like or something like that. These are very intent things. If you're just clicking around the internet, you don't have an intention to share anything with anyone. So that's one thing. And then the other thing is that there's a danger a bit to make people paranoid, and to leave them a little bit helpless as to what to do, because of course, NIM is aimed at providing a layer for metadata protection. But whether people are able to use these kind of protections in all their activities is it's not so simple. And they might live with the fear that they are exposed and feel that they are helpless. So that's a bit a problem you might find.
Well, two
I
things.
would
One is yeah.
no, go ahead, Dustin.
No, I really like that analogy, actually, that metaphor. And I think maybe this is where some of this communication stuff lies, is actually good at having good metaphors, and the metaphor of the body language is really cool. Oh man, I forgot my other point, Simon.
All right. Well,
You go ahead,
actually,
and then I'll think about it.
all right, because I also love the analogy, and actually, I'm going to continue this analogy because I would like to talk to you about something, Claudia, that or rather make you talk about something that I think you can't really discuss metadata surveillance without, like especially metadata surveillance to make it relevant to any degree, and that is machine learning, right? I would like to hear in all of these examples that you brought, like what the role of machine learning is, and just
Yeah.
to continue the metadata to content is to content, what body language is to what you say. Um, let's also talk about how machine learning is basically deaf, right? And it's really great at reading your body language, but not so
Yeah.
great at hearing what you say.
Yeah, I mean, natural language is hard. I mean, natural language is hard for machines to make sense of, because like even a machine that is very well trained, like maybe you and I have our own language that when we say a certain word, it means something because it's an inner joke or whatever, right? Like making sense of natural language is hard, while making sense of metadata for machines is easy because it's the language of machines, right? Is internet address, IP addresses, times, number of bytes. These are all things that are kind of very clear to machines. They have numbers and they're very clear. They don't have to kind of infer meaning. I mean, they know the meaning. The meaning is that there are so many packets. The meaning is that this is the destination, right? They don't need to kind of have some sort of interpretation layer there. You were asking, the first question was?
Yes, sorry, I asked two questions in a very long way, so sorry for that. It's really difficult to remember. So my first question was in all of the things that we discussed so far,
Machine
like
learning.
all of these techniques, how in what ways was machine learning
That's a great
involved?
question. So yeah, that's a really good question. So I mean, machine learning has made the problem much easier for the adversary, right? But I have to say that before machine learning, we had all these attacks already, you know? But before you had to, I mean, it was, you had to be, you had to do more work.
Sure.
You had to do more work in that you had to have like, okay, what's you had to do kind of manually the matching that the machine learning is doing now automatically. So for example, this, yeah, you can have techniques that try to say, okay, I'm gonna have a statistical model of how this thing is working, and I have some input and I have some output, and now I can see which output is the closest to the input. So it's not like you're kind of doing this matching, this learning, but you're doing it in a not with a classifier, a machine learning classifier, neural network or something like that, but you're doing it kind of by hand, right? Like, okay, so I will assume that the packet coming out is this packet, blah blah blah. Now, machine learning has made it much easier because now you can handle data that is noisier. You can find patterns that are not so obvious to find. Like before machine learning, you needed to have a kind of a more structured behavior that you could characterize in a probabilistic way, and then you could kind of do some Bayesian inference to recover the quantities of interest, right? Machine learning can tolerate noise better and still find patterns, and it can also learn from very vast amounts of data. So it has definitely made the problem a lot more difficult to counter. Yeah.
Yeah, and makes it more accessible, makes it cheaper for than smaller players to use, like we were
Yeah.
saying before, marketing, you know.
Yeah. Not only, but also like they can feed large amounts of data to these classifiers, while before you needed to have some sort of analytical model of things.
Then I guess what comes to mind when I hear machine learning, because I know that the NSA's PRISM program, for example, is heavily based on machine learning. So it's not really enough, of course, to sort of hoover up all of this data, which the U.S. government hoovers up according to the Snowden revelations, right? You also need to make sense of that, and I guess without machine learning, also advanced machine learning, it would not be possible to make sense of the communications of literally millions of people.
Yeah, it's hard to, how do you handle all of this, right? You want to find patterns, like doing it with a script. Is definitely machine learning has changed the game and has made it possible to handle this vast amount of information and the revelation of any patterns that might be hidden in them. So yeah.
All right, I'm really, I want to respect your time, and you said that you have a hard stop at 5, so I want to be mindful of that. So I offer you two ways to spend the final 5 minutes. One is to talk a little bit about website fingerprinting, or we can also give people some positive vibes when it comes to all of this surveillance methodology that we discussed. How do you stay positive in knowing that this happens? You can choose either one of those.
Okay. Oof. I guess we can take some questions and see.
Okay. All right.
I had a way to frame that, actually, the positive aspect. Is that okay? It was back to a previous thing I wanted to touch on. Because what we were saying before was like, I was asking a question about, well, I guess conveying to people about these things can make them feel paranoid. Is there a way we can flip the switch then and talk about, okay, well, how do we then tell people, or how do we convey a future or that feeling when metadata is not collected about you, when you are aware of how it's being used? Like, how do we convey the other side?
Yeah, I mean, the first thing we need to do is to have solutions, right? So I think NIM
Yeah.
is working hard in providing solutions that address this problem. So I think if once we put solutions in the hands of people, we can have a more positive message, right? We can say, well, here's something that you can use, and then all of these problems that maybe you were not super aware of, but were actually there, are now mitigated, right?
Mhm. That's great. Thank you. Anyone else? Sorry.
There is a. Wait a second. All right. So, relativism is asking, how does NIM approach attack surface? Because NIM seems very complex. I'm not sure what the question means, but hopefully you do know, Claudia.
Yeah, I mean, there's some things are outside of the attack surface, right? So in particular, the device security. So if your phone or computer is compromised, yeah, that's kind of outside of the threat model, right? Otherwise, I mean, yeah, indeed, there is quite some complexity, and yeah, we kind of have to be very thorough in defining the possible threats. So both threats to anonymity, but also threats to other kinds of abuse, denial of service, stuff like that. And then to see like what the different entities, what adversaries with different capacities are able to do, and where and what are the things stopping them from getting what they want, right? Like countermeasures. But I think, to me, the main thing that is really outside of the threat model is the device security, because that's a whole other game. And frankly, all of these networking solutions, they kind of rely on your device not being owned by the adversary, because if I can put some malware on your device, and then I don't even need to break anything in NIM or anything, I can just see everything you're doing. Right?
Yeah. So it's worth mentioning. It comes up in conversations from time to time, but I think it's worth sharing here too that NIM is not targeted to solve problems or protect against things like Pegasus, for example. That's a very very targeted attack against one particular individual, which needs to be injected somehow, which is like a person-specific thing. We're more focused on protecting people from mass surveillance, right?
I think one way to put it is that just as we now are in a world, I mean, and this was not always the case, but now we're in a world in which most communications are just encrypted by default, right? Most information exchange is just encrypted end to end. And this provides like a basic level of security for everyone. NIM is basically taking this to the next level and saying, okay, let's also have networking infrastructure that is not only protecting the content, but also the metadata that is being exchanged, right? So it's kind of a general layer of protection so that the metadata is not readily available for any intermediary to just grab and analyze and learn things from it.
All right. Well, on that note,
Fantastic.
Claudia, I think we arrived to the end of this call because it's 5 o'clock and you have guests
Perfect.
coming over.
Thank you.
Thank you so much.
It
Okay.
was
Great.
I hope
it was
it was clear.
no, it was very clear. It was amazing to hear from you once again, and you can take it as a threat. I'll be having you back at some point on a community call. Uh,
Sounds great.
it was lovely to talk to you, Claudia.
Have
Okay,
Have
a
a nice
lovely evening.
everyone, and have a great weekend.
Thank you.
you
To
too,
take
Claudia.
care.
All right, folks. Well,
Cool.
that concludes our Data Privacy Day special. Hopefully, you guys enjoyed it and learned something. How did you feel about it, Vesta?
Yeah, that's a lot. I was taking some notes in as well. Um, I'm going to be using things differently. I mean, you're already aware of some of these things already, but just having someone explain it like that, it really hones it in on how urgent it is.
Yeah, it's super fascinating, and of course, Claudia works
Mm.
in privacy research. So when she says they looked into that, she's talking about people who are working in the same field as she does. It's really fascinating to hear these things straight from the horse's mouth. It's absolutely fascinating what kind of things can be discerned from people's metadata. Thoroughly
Yeah.
enjoyed it.
Thank you all for listening in as well. Really, it's really nice to have you all here.
Yeah, exactly. And also, Jamie, super sorry for not asking your question, but but I saw because Jamie asked us, "Hey, how exactly can our ISP not read our data while using the mixnet?" So there was one minute left when you asked this question, and I knew that it was not going to be a 1 minute question. All right, folks.
Cool
Well,
shit.
with no further ado, Vesta, do you want to tell people where they can claim their POAP for this prestigious event?
Yes, of course. So just in the right below the community call channel, we have the claim attendance channel above the NIM stage. If you go there, there are clear instructions on how to claim your POAP, which is always the best, funnest thing to do.
Exactly. So, folks,
Yeah.
thanks for joining our Data Privacy Day special.
Yep.
Actually, Data Privacy Day is going to be tomorrow. So, if you can do something to keep in mind data privacy, maybe share some of the thoughts that you learned here with friends and family. Don't be a bummer. Don't tell them that the world is over and we're being watched all the time. Don't make them paranoid, but try to give them some tangible ways of protecting their metadata and maybe raise awareness of these issues. And as usual,
Maybe,
the call. Oh, sorry. Go ahead.
yeah. So I just have an idea. I mean, maybe within the community, there's a way. We'd love that. We can within the community share. I don't know, like a photo filter or something that we can do to kind of spread that message.
Yeah, we
Just
could
putting an idea.
definitely do that. It's a great idea. Yeah. Oh, as usual, just the usual housekeeping items. The call was recorded, although I owe you quite a bit of backlog of uploads, but I'm at one point I'm going to upload all of them, hopefully this weekend. So once that happens, you can find the recording of this dedicated community call playlist on our YouTube channel. And also point out that besides Data Privacy Day, this community call was also dedicated to El Turco. As many of you know, our Turkish speaking community manager El Turco, who basically built the Turkish community from the ground up, has passed away recently, which is absolutely tragic. And I would like to dedicate this community call to him. And actually, the first recording that I ever uploaded to YouTube was with him. So maybe you want to give a listen to that. I tried to write a goodbye message to El Turco on Telegram. As it turns out, it is something really difficult to do. I wrote 2 short paragraphs, and even that took me almost an hour. And I don't like what I wrote. I didn't put any of his person in there. So I would like to share that I knew El Turco as a cheerful, hot-headed guy with a very strong and powerful personality who was no pushover. He was a very lively and strong person, and it was amazing to get to know him. And besides that, when it comes to his work, he got in crypto early. He understood crypto pretty well, and instead of cashing out on that, he created a huge community of thousands of people and actively helped them out over multiple years to catch up on crypto to avoid scams, to understand this really complicated space that we love so much. And if you just look around on our Turkish community channel, or if you look around on Testnet Run, which was Alturko's community, which he initially built, the messages that you see there are absolutely heartbreaking and also heartwarming. This guy really touched a lot of people's lives, and it is a pretty sorrow goodbye. It came very suddenly that he passed away, and this community call was dedicated to also saying goodbye to him. So on that kind of sad note, I would like to wish everybody a great weekend, and hopefully you learned something today, and see you all next week. Ciao, ciao.
Take care of yourselves. Bye.